Okay, so last week we talked about if we have these logarithms that they have to have the same base. Okay, the bases have to be identical. Okay, if they're not, then you cannot do this. Okay, but if we are taking the logarithm of some value m plus some logarithm of value n, okay, we can transform that into a logarithm of the product between m and n. Okay. We did the same thing with difference. Difference turned into a quotient. Okay. And the one that we haven't, I don't know why it has G. Did you guys have a G on yours? On the printout here? Right here. It does say G on yours? I don't have G. This property exists as well. And the reason this property exists, think about this. If I have log of, let's just go m plus log of m plus, and I keep doing that, keep adding logs of m together, okay? But I say I do that n times, okay? Wouldn't that turn into log of m times m times m times m, but n times? And if I have m times m times m times m, how can I rewrite that in a more convenient way? I can use exponents. Does that make sense? Okay. So that's kind of what we're getting at there with that rule. We haven't used that one too much, but that's, if you remember from, I think it was Tuesday last time we did this, we went through and did some of these examples. Okay, so my assumption is you probably already got these down there, written down, so we're not going to go through those again. But we'll start off here with this one that says 4 log 10 of m minus log 10 n. Okay. As you go through these, and it's very relatable to PEMDAS, order of operations, if exponents exist or could exist, you need to take care of those first. So if there's ever a coefficient out in front here, like that 4, you want to rewrite that so that it turns into, you take that 4, you're going to put it right there as an exponent. So it's going to turn into log base 10 of m to the 4th. Okay. Now it'll be minus log base 10 of n. I'm bad at it, but I think it makes things easier if you put parentheses in, because then when we do, like, since we have subtraction here, basically my statement is going to be, when we have subtraction, you take the argument, which is the thing in parentheses, and you divide them by one another. So it'll be parentheses divided by parentheses here. So this is going to turn into, okay, because it's subtraction, subtraction turns into division. And subtraction and division, order matters. So if this is m to the 4th minus n, it's going to turn into m to the 4th over n. Okay? And we know that we're done when there are no more addition signs, no more subtraction signs, and no more coefficients in front of the logarithm. Okay? Now, we may have absolutely no idea whether we've done this correctly. How can I check to see if I've done this correctly? Okay, so I'm going to go to Desmos. Okay, so we're in Desmos. We're going to type in what we started with. So I'm going to type in 4 log of m minus log of n. Okay? Now, it doesn't know what to do because it doesn't know what m and n are yet. And I can take care of that now, or I can worry about it later. I'm going to worry about it later. Okay? But that's exactly what we started with, right? Okay? Now I'm going to type in what we developed. So I'm going to go log m to the fourth divided by n. Okay? So you type what you started with, and you type what you ended with. And now it's going to ask you to create values for m and n. We haven't talked too much about this, but the only thing that has to happen is that you have to take logarithms of 0 or positive numbers, okay? Actually, you can't take a logarithm, sorry, not 0. You have to take a logarithm of a positive number. So as long as m and n don't, either one of them end up being negative, we should get a solution here that makes sense. So I'm going to ask it to create these sliders, okay? And now as I move those sliders, no matter what I move them to, and it puts m and n in these spots here, and puts m and n in these spots here, do these two numbers equate? Yeah. So what's that tell me? What's that tell me about that thing compared to that thing? They're equal. They're identical. Okay? So I've done this correctly. Does that make sense to everybody? Okay? If we get a negative, you see there that's undefined. Here is also undefined. So that's, you cannot take the logarithm of a negative number. Okay? Cannot take the logarithm of 0 either. Okay? So I want to do that every time we do one of these. Obviously, if they, like the ones we've done previously on Tuesday, they were all numerical. There were no variables, so we could just type it into Desmos and see what it gave us. Okay. With that one, you cannot do that. Let's jump down. Let's skip this one. Actually, you guys do that one. You guys do that one on your own real quick. All right. So addition turns into what? Multiplication. So it's going to rewrite as log base 10 of 7 times 2, right? So 14. Okay. Now, our calculator will help us here, but what we need to realize is, so if I go log base 10, so if I don't write the base in here at the bottom, then it's going to automatically use 10 as the base. Okay with everybody? So log base 10 of 7 plus log base 10 of 2, does that end up being the same as log base 10 of 14? Are those numbers the same? Okay. Also, what we can figure out here is that if I go log base 10 of 7 and log base 10 of 2, what do you think I'm going to get if I add those two numbers together right there? We'll get that number right there. Okay. So it's this process is taking these values and combining them with something more efficient for us, one singular value. So this is saying that I need to raise, if I raise 10 to that number right there, I should get 14, right? That's what a logarithm is, so let's try that. If I go 10 raised to the 1.14612803568, do I get 14? And the only reason it's not 100% 14 is because that number right there is rounded. What do I need to do with this 5 before I do anything? Make it an exponent. So we get 7 to the 5th. Plus then log base 10 of 2. Now with that multiplication, with that addition, what does it turn into? Multiplication. So I'm going to rewrite this now as log base 10 of 7 to the 5th times 2. Now, just depending on some of these numbers, like 7 to the 5th is that number there, pretty big, but not undoable or non-doable. So we're looking at now, when it says log base 10 of 7 to the 5th times 2, it's actually 33,614. 33,614. 614. Correct. And parentheses are the best thing to do. The best thing to do. So you're saying like this 7 to the 5th, put that in parentheses? Like that? Yes. I agree. Nope. You're good. So now if I ask the calculator, what is log of 33, 614? Okay. It's that number right there. So that's what I need to raise 10 to. Because it's always what I raise my base to get that 33,614 number. Is this okay? All right, let's do these. These are a little bit more difficult. Okay, so what is the first thing you have to do? Take the exponents up. Okay, so this number here is going to become an exponent for that 2. This number here is going to become an exponent for that x, right? So I'll rewrite this as log base 3 of 2 to the 1/2 plus log base 3 of x to the 1/4. Is that okay? Now, if that's addition, what does that turn into? Multiplication. So I'm going to take this and I'm going to multiply what's in the parentheses together, right? So when I multiply the stuff in the parentheses, it's going to turn into log 2 to the 1/2 times x to the 1/4. Okay? Which generally is okay to write it that way. But yeah, 2, so the 1/2, rewrite that as 2 to the -2. That would be okay. I'm going to go a different route. Because usually we don't like to write an answer, present an answer with a negative. The only reason I think we did that maybe Tuesday or Monday. The reason we did that then was because it allowed for some algebra to be done that presented a relationship that was useful. But if I'm going to present this as a final answer, this would be okay. Does anybody remember if I have this is called a rational exponent, how we can rewrite that? 2 to the 1/2 is equal to what? Do you remember what, if I wrote this, 9 to the 1/2 is 3. 16 to the 1/2 is 4. Well, what am I doing with that 9 to get 3? It's exactly that. It's square rooting. Okay? So 9 to the 1/2. 9 to the 1/2 is the same thing as the square root of 9. Remember taking that number right there was the exponent for the 9, and that number right there is the root that we're taking, right? So 16 to the 1/2 would be that. So 2 to the 1/2 would be square root of 2. Does that make sense? Okay, so I'm going to rewrite this as log, this is base 3, of the square root of 2. What's this x to the 1/4 going to become? Fourth root of x. The denominator of the exponent is the number out front of the radical. It's the index. Okay? And then the numerator of the exponent is the power of the radicand. Okay? So those are the same thing. But my hope is, whether we remember that or not, my hope is that we vaguely remember that. And this is just math in general. we go through and we learn some of these properties, and my hope is that, and I think it kind of struck a note that said, I vaguely remember seeing this. So if we're working on our own, we're working in some other context, maybe a job, and I say, okay, I need to do this procedure. I vaguely remember it, not 100% sure. Can I go back and learn it real quick? Does that make sense? So we could, okay, if we vaguely remember this, go back, okay, let's go back to chapter 6 and say, what did we learn from chapter 6? Where was this again? And that process right there kind of jogged your memory, right? That's math in general, okay? If I've seen it once, can I learn it to an extent where if I see it again but don't know how to fully use it, can I go back and reteach myself quickly, okay? In addition, hopefully it demonstrates the necessity that in a math class, once you learn something, can you forget it? You can't. It happens, but should we forget it? No, okay? Because if I forget it the moment after I take a test or a quiz and I forget it, then the more I have to do of that going back and finding and reteaching, right? Okay? And we want to minimize that. In rock class, okay, or in English class or something like that, you guys read Mice and Men in Mr. Styles' class when you guys were, okay, so in Rube's class. So once I read that book, can I forget everything I read in that book when I have to read the next one? Yeah. Okay, but the whole thing, though, like there's themes and structures of writing and stuff like that that should be carried over to the next thing that you read. But if I'm in a science class and I'm talking about the water cycle, and I don't understand how that works, but next week we talk about DNA, did I need to know anything about water cycle? Not really. Okay? There might be links at some degree, but I don't need to know anything about it. So I can maybe in those classes do that. But in a math class, what you see day 1, you're going to use day 2. And what you see in day 1 and day 2, you're going to use in day 3. And that goes on forever. Okay? If I want to check this, because I think this was a more difficult one, let's type it into Desmos. So we got 1/2. Now, if I want to use a different base here, and they say base 3, so in Desmos, you have to grab your calculator. You have to hit that keyboard icon. Go to Functions. Go to Miscellaneous. Then you'll come down here where it says log base A. Put a 3 in there. What I like to do, if I know I'm going to use this a lot, I will highlight that and hit Control-C, because that copies it, right? And then I can type that in. I can hit Control-V. I paste it as many times as I need later on, and I have to go through all those buttons. Then 2, yes. Control-V, that's just what it is to paste. I don't know. Because it's right next to C. Okay. So the only thing here is that, and we could do this 2 different ways. Because it uses X, it's going to try to graph it. Okay. So if I just want to evaluate at a single value, maybe I choose X to a different letter. Does that make sense? But it's not a huge issue here because we can do this. We can go. If I want to go log base 3, we said it should be the square root of 2, okay, and then the 4th root of X. And the reason it's okay to graph is because it only used the variable X. And when it graphs them on top of each other, right? So does that tell you that they're right? Okay. And what that's really doing is it's showing you that no matter what X is, the Y values are identical, meaning that if I did change this to an A and change that to an A, what it's doing is saying, okay, when A is 1, they both plot at a Y value of 0.315. If they're both A of 3.6, so this is essentially the X value that would be plotted, I could plot that point there, a Y value of 0.6069, okay? But they are always the same. So did we do this right? Yeah, okay. see what you can come up with just doing right now. I know there's three parts to this, but right now I just want to see you guys come up with what that turns into. Don't do the last part, because once you get the blue part, we'll then attack the last part, okay? When there's multiple adding and subtracting occurring throughout the problem, first you got to do with exponents, right? But then it's add and subtract. You do them as you see them left to right, just like we do in order of operations, okay? So that's why I'm going to highlight those two blue ones, because those are the two that you would do right away. So the x becomes an exponent. So we got log base 4 m to the x. That's what that turns into, right? Okay. Plus, what's that going to turn? What's that 1 to the y going to do? That's going to become an exponent. So n 1 to the y. Okay. I'm going to bring down I didn't ask you this, but I'm going to bring this down just so it stays here. What are you going to do with what I've got highlighted here in blue? Combine through what operation? Good. So it's going to be log base 4 of mx, or m to the x, n to the 1 over y, right? Okay. So you've merged those left to right. You dealt with that addition, right? It became one thing. Now it's minus log base 4 of p. What does subtraction turn into? Division. So I'm going to take the things that are in parentheses and divide them. So it turns into log base 4 of m to the x, n to the 1 over y, over p. Is that okay? Now you can leave it that way, and that'd be a fine answer. But how can I readjust that 1 to the y for this n? You could make an n to the negative y, but again, that would be a negative exponent. That would be a negative exponent in our answer, and we don't like negative exponents. Is that like saying n to the 1/2? Where if it was n to the 1/2, then we take square root of n? Okay. If it was n to the 1/3, it'd be the third root of n. If it was n to the 1/4, it'd be the fourth root of n. It's n to the 1 over y. So now we write it as the y root of n all over p. And again, we want to check that. So it started with x log base 4 of m plus 1 over y log base 4 of n minus, all right, so that's what we started with, right? Okay. That should be log base 4 of x. So that is the thing that we started with. Okay. Now, because it's got x in here, it's not graphing anything over here because I haven't told what m, n, and p need to be. Okay. But when we were done, we had log base 4. Okay. We went m to the x. Okay. Now, I'm going to type it in as a square root, not square root, a y root. So I go there, but put a y right there, and then in, divided then by p. Okay. So now once I ask it to create all of these sliders, okay, what's the problem here? Try adding an equal sign to turn this into, I don't want it into an equation. I think I had this typed in wrong. All right, so what I think is happening here, so make sure I type this in right. I think it's having issues because of the complexity with the x. So x log 4m. Okay. So here's the problem. Because it chose in the original problem x's and y's, Desmos is a graphing instrument, right? So when it sees x's and y's together, it expects an equation. Does that make sense? I don't want necessarily an equation here. I don't care about the graph. So what I'm going to do is everywhere I see an x, I'm going to replace it with a different letter. So let's just use A. And then up here, I'll use A. And everywhere I see a y, I'm going to replace it with a different letter that I haven't used. So B. And then here I'll use B. So now it's asking us to adjust all those things. Can I move this? There we go. So let's see if I change A, change B, change M, change N, and change P. So those are some pretty random values I chose for A, B, M, N, and P, right? Go back up to the two things. Are they the same? And if I just stop them anywhere randomly, are they still the same thing? So that's a way to use your calculator to help yourself. And I think that's a good example that to understand the way a lot of your calculators are designed, understanding that X and Y. If I'm just trying to get my calculator to evaluate things, maybe X's and Y's aren't the greatest letters to use. So you can redefine them. You can change them as long as you keep track of what you've changed them to. So I changed X to A. So everywhere that I saw X, it had to always change to A. I changed Y to B, and so everywhere I had Y, it had to change to B. Does that make sense? And then you can use your tools to help. Okay. All right, let's stop there for today. I think in the next couple of days we're going to practice more of this. Okay. I'm going to open up an assignment. I believe it's 7.4. I'll open that up here soon, and that'll be due on Wednesday.